Where do I set that?
Oh. I have you. It looks today I'm going to do a little bit.
It looks like no sense.
You are.
Yeah.
I'm just trying to see if I'm going to leave everybody where they're at for now.
Did I do that one right? I think it's wrong.
No negative exponents, so there should be no to the denominator. And then yes. So it'd be.
So it'd be x1.
It'd be y to the ninth, or whatever that is, over 4x to the fourth.
And then that one, I'm confused about just because how did the exponents do it?
Yeah, just go ahead and do your division here, and then subtract your exponents. So let's see if you go. So that should be mid down.
Coefficients, maybe that's how to do it.
Yeah, you just divide the coefficients up and All right, so before we get started today, I want you to get out any homework assignment that you have for me. So 7-1, 7-2, anything from Unit 6, go ahead and get those out. Make sure your name's on them. I'm going to collect those. And then I'm going to get started on today's lesson. All right, I'm going to get that homework started. That's 6-5. So, all right, so we're going to go ahead and move on. And today's lesson is kind of a two-parter. The first part doesn't necessarily fit with the second part. There's two things I want you to be able to do. I want you to be able to rewrite expressions involving rational exponents. I'll get into that in a minute. And then the other thing is I want you to be able to solve equations involving rational exponents. So this is 7-3. And call that rational exponents. So the first thing I want you to be able to do, and this skill aside from actually solving the equations, you're not going to use this particular skill in solving the equations, but this is something that I want you to be able to do when we're dealing with rational exponents in general, is I want you to be able to take an exponent or an expression that's written in exponential form and convert it to radical form, or go from radical form back to exponential form. So let me start with the basic of a radical. This is a radical, okay? And The number underneath the radical is called the radicand. I don't really particularly care if you know that by definition. But the number that you will see here, and if there's not a number here, in this spot right here, then it's a square root. It's a 2. But if there is a number there, then it's a cubed root or a 4th root or a 5th root. Okay, so that's what it's asking for. So if I put a 5 here, this is asking for the 5th root of x. Okay. Now, if there's no exponent with the variable that's under the radical symbol, okay, so there's no exponent showing, then you know it's assumed to be 1, right? So to rewrite this without the radical, okay, to rewrite it without the radical, I'm going to take the radicand, that's the x to the first, and I'm going to take this index, that's what they call it, the index, and I'm going to make that my denominator. So that becomes x to the 1/5. Understand that the 5th root of x, the 5th root of radical x, is the same thing as x to the 1/5. So if I gave you this problem, let's see, if I did, for instance, b, right, that is the same thing as b to the 1/2. 16 is the same thing as 16 to the 1/2. So to go from radical form to exponential form, you take the index and you make that the denominator. Even if you already have, I'm just making this one up, even if you already have a numerator that's not 1, to put this in exponential form, I would just make that 32 to the 4/5 power. Okay. Now the reason I want you to be able to do this part right here, is soon we're going to be evaluating radicals. And even this one, you might not know what that's asking you for. You might not understand what I'm asking you to tell me, but I can tell you this. If you take this and put it in your calculator, 32 to the 4/5 power, I think you should get 16. Because it's a base of 2. Okay, this just helps you solve these. So I want you to be able to go from this form to this form, and this is separate from what the equations I'm going to be showing you today. Okay, I'm not assigning homework over this part. The homework I'm assigning comes over solving exponential equations. And an exponential equation is an equation written with exponents. So for example, we're going to say solving. And I'm going to start with an easy one, okay? If I take 6 to the x power and say that equals 216. Okay, 6 to the x power equals 216. And I want to solve that for x. I want to find out to what power I have to take 6 to get 216. Now, like I said, this is an easy one. So, you might be able to look at that and kind of guess and check on that. But I don't want you to think that's the only way to do it, because some of these do get a little bit more challenging. So I want you to know that to solve an exponential equation, and that's what that is, the bases have to be the same. So in this case, I'm going to use a base of 6. Okay, because if I used like 2, there's nothing I can take, like no power of 2 that I can get 6 with. Okay, that's like 2 squared is 4, 2 to the third is 8. There's nothing I can multiply as far as 2 to itself by to get 6. So I'm going to use a base of 6. And what I have to do is, and this is just, unless you just know off the top of your heads, this is just kind of a guess and check with your calculator, okay? This is just where you grab that calculator and you say, okay, I know the base is 6. So I'm going to take 6 to some power. Okay, so I'm going to rewrite this as 6x and then 6 to some power. I'm going to put that right here. Okay, and I just have to figure out what that is. So I just, with my calculator, I just would start. You know it's not squared, okay, because you know 6 squared is 36, right? So I would go 6 to the third power and see if that's it. And it is. 6 times 6 is 36. 36 times 6 is 216. So I know this is 6 to the third power. Let me write that a little bit bigger. Okay. Once your bases are the same, okay, once the bases are the same, you're going to set your exponents equal. It's either going to give you the answer or you have to solve from there. In this case, it gives us the answer. When I set these two things equal, I get x equals 3. And that's what this x was. It was 6 to the third power. Bases have to be the same, and then you set the exponents equal. So let me do another one, another couple. So let's say I give you this one, 25, 2x minus 1. Okay, I didn't mean to do that. Get that out of there. It's just x minus 1. It's not 2x minus 1 equals 5 to the first. Okay. In this case, remember, the bases have to be the same. And when I'm talking about bases, remember, I'm talking about, when you have a base here, this number here, whatever you're going to take to the power, those bases have to be the same. So what do you suppose, if I've got a base of 5 here and 25 here, what do you suppose, what's the base I should be using?
5.
It's 5. It's 5. So you're going to want to rewrite this 25 in exponential form with a base of 5. So we're going to rewrite 25, its equivalent expression, with a base of 5. What would that be?
5 to the second power.
Yes, 5 to the second power. Would everybody agree that 5 to the second power is 25? Okay, so I'm going to take this 25 out, and I'm going to put 5 to the second power in, and then the x minus 1 beside it. That doesn't go away, that's still there. And I'm going to set that equal to 5 to the first power. And now the bases are the same, so to solve for that x, just set those two things equal to each other and solve for x. So 2x minus 1 equals 1. 2x minus 2 equals 1. Add 2. 2x equals 3. Divide by 2. So x equals 3 over 2. So x equals 3 over 2. Okay? Now, you've never solved equations like this before, so I would imagine it's a little bit tricky. And the hardest part is determining what base you want to use. But you have to have the same base. And when I'm talking about exponential base. Okay, it's not just the same number. It has to be the same base that you can take, that you can write in exponential form. So let's look at another one. So let's do 12 and then 2x plus 3 equals 144. Again, these are a little bit easier if you know your perfect squares.
12.
Because 144 is a perfect square. The base of this is 12. So I could just rewrite it as 12 and then 2x plus 3 equals 12 squared. Set your exponents equal and solve. 2x equals negative 1. Divide by 2. X equals negative 1/2. Sometimes, I'm going to work one of these out. Sometimes you have to change both numbers. Here is why. If I did 4 is not the base, exponential base of 32, okay? I can't take 4 times itself any number of times and get 32 because 4 times 4 is 16. 16 times 4 takes us to 64. So this can't be the base. So it has to be smaller than that. So if you had to guess, hopefully you'd guess 2. Yes. So we're going to go with a base of 2, which means you need to change both of these numbers. This becomes 2 squared. And if you don't know it off the top of your head, you get your calculator and you go, okay, you know it's not 2 to, hopefully you know it's not 2 to the 3rd power. You know, start 2 to the 4th power, 16. 2 to the 5th power is 32. So you're going to change this to 2 to the 5x power because that x is going to stay. And that's going to give you 5x equals 2. Divide by 5. So x equals 2/5. And what you found, okay, is if I take that 2/5 and do 32 to the 2/5 power, okay, that means you're taking the base times itself twice, so 2 times 2 is 4. This tells you your answer is 4, but it also shows you what you can put in your calculator to get 32 to the 2/5 power. That's a skill you're going to need for Algebra 2. I know it's confusing. The hardest part's going to be finding the base. But what questions do you have about just the basics of solving these? Probably not going to know you have questions till you get started on it. So why don't you go to Canvas? You're going to do, it's 45 through 56 all. It's 11, 12 problems total. Why don't you start? Start working on it. If you have questions, ask. I have the key. I'm going to put the key up here on the board for you to see. Anybody online have any questions? Remember to solve these. Your bases have to be the same. Here's the key. Okay. I'm going to put it up here so that once you've worked out a few, if you want to have a check to see, you can. Or if you get totally stuck, and I don't mean just going to copy it down, but if you get really stuck on something and you can't figure out the bases, you tell me what to see what bases I use. There's that. I'll make it here for you. Yep. The bases, yeah, the bases would have to be the same. So, like, there's one that is like 9 and 27. Or 9 isn't the base for 27, so I can change both those bases to 3. Yeah. Yes, it is. If you finish in class today, I'll take them today. If not, I'll get them later, but